Hello everyone, we are Team 26 and today we are excited to share our project, a diabetes risk prediction tool designed to help users assess their risk of developing diabetes so that they can take proactive steps toward prevention. Here's a quick overview of what we'll be covering today. We'll start with some background about diabetes, then we will walk through our project's goals, the approach we took, and some of our key achievements. We have a live demo of our application to show how everything works. Finally, we will wrap up with our conclusions and suggestions for future directions. Before we begin, let me introduce our team. We are Team 26. My name is Ranjini and I'm joined by my teammates Nate, Ahmad, and Yangche. Now, diabetes continues to be a major public health issue, currently affecting over 38 million Americans. The vast majority, around 95%, have type 2 diabetes, which could be preventable or manageable with early intervention. Unfortunately, many people don't realize they are at risk until symptoms have already developed. This delay in awareness means they miss crucial opportunities to make changes or take action. Even though a large number of people are at risk for developing diabetes, only about 500,000 have participated in formal prevention programs. That's less than 1%, which shows a huge gap in outreach. Part of the problem is awareness. There are still common misconceptions like the idea that only sugar causes diabetes or affects blood sugar, and this can lead to poor health choices. And finally, the current tools for assessing risk have some practical issues. Many require real time glucose monitoring. These devices are expensive and sometimes they need costly subscriptions. Otherwise, we would need regular clinical visits, making them less accessible for people who just want a quick and simple way to understand their risk.
Our group's main goal was to develop a low-cost tool that allowed individuals to estimate their risk of developing diabetes, as well as make awareness of different mitigation strategies. We first needed to find a database that linked behaviors to diabetic outcomes. The CDC Behavior Risk Factor Surveillance System survey data is one such dataset. We found an example of this dataset post-clean on Kaggle.com. To process this data, our group decided to use the Python programming language and libraries such as Pandas, NumPy, and scikit-learn. Scikit-learn was used to train a random forest model on the survey data, with the outcome being a prediction on whether the individual would develop diabetes. Our team then focused on deployment. Our front end was developed using a Python library called Streamlit, and our back end was developed using Fast API. We Dockerized both halves of our app and deployed them on Railway.com.
Here's a quick overview of each team member's contributions. Nate focused on training the AI model and handled deployment, working through challenges like platform compatibility and model integration. Ahmed, worked on the front-end development, creating visualizations, especially those highlighting risk factors like age or BMI, helping users better understand their results. Yangche took charge of project management, ensuring tasks stayed on track, while also working on back-end development and conducting QA testing. Ranjini worked on front-end development, designing the Streamlit site pages and built out the site navigation, making sure users could easily explore the different features and results.
For this project, most of our research was technical in nature. We looked into various machine learning models suitable for risk prediction and chose gradient boosting because of its performance with tabular health data. And we also studied Streamlit's documentation to follow layout conventions and ensure responsiveness, especially for mobile access. On the deployment side, we spent time researching how to package and host our app. We found that Streamlit and Docker work well independently, but had compatibility issues with platforms like GitHub Pages. This required extra investigation into alternative hosting options. We also reviewed the structure of the Kaggle diabetes dataset to understand its strengths and limitations. Through correlation analysis, we identified which features were most predictive for diabetes risk, but we also ran into a few challenges. One of the biggest gaps was the lack of comprehensive features, with important variables like diet, family history, and socioeconomic status were missing. Additionally, there were naming inconsistencies across diabetes indicators, which made standardization harder. Overall, our research helped guide both design and implementation, but it also revealed common limitations in publicly available health data and deployment documentations, which are areas worth exploring further in future work.
So, when we started this project, our goal was to create something that not only informs people about their diabetes risk, but actually empowers them to take action. We began by building a tool that gives people personalized feedback based on their lifestyle, background, and health history. Something that feels relevant to them, not just general advice. As we developed the platform, we knew we didn't just want to show numbers. We wanted to make the data meaningful. So we created interactive visualizations that help users explore health trends in a way that's actually engaging and easy to understand. On top of that, we built a high-performance model. Behind the scenes, we focused on making sure everything was secure and stable. We used Docker and deployed the app through railway.com, which gave us flexibility and peace of mind as we iterated. And all of this was grounded in real-world data. We used the CDC's BRFSS dataset, which not only informed our feedback model, but helped us align our work with larger national efforts in diabetes prevention. From start to finish, whether it's data wrangling, design, coding, or even deployment, this project was a true team effort. We each brought different strengths to the table, and in the end, built something we're generally proud of.
As we worked through multiple sprints, we encountered several challenges that helped shape our final product. First, we had to rethink the layout of our homepage. Our original mockups were based on a standard website structure, which didn't mesh well with Streamlit's design principles. Streamlit apps work best with sidebar navigation and a more app-like layout, so we redesigned the homepage to follow those guidelines. The sidebar made the app more intuitive and mobile-friendly, aligning better with how Streamlit apps are intended to function. In terms of project structure and planning, it took some time to align as a team on how to move forward. We had different ideas and had to prioritize what to focus on first. One major area was deployment. Streamlit, Docker, and GitHub pages don't play nicely together by default, so we spent a good amount of time researching alternatives and figuring out how to host the app without reworking everything from scratch. When it came to visualizations, we ran into technical hiccups with the plotting API. Specifically, we had issues saving and displaying the graphs correctly. We had to troubleshoot things like file paths, formats, and ensuring that the plots were accessible to the front end without breaking the API. Another big challenge was choosing a deployment platform. We assumed that containerization would make things easier, but many platforms either didn't support our stack, were too expensive, or made deployment more complex than expected. Lastly, we faced some data challenges. The dataset had inconsistent naming for diabetes indicators, which made it harder to standardize our risk analysis. We also had to do some deep correlation analysis to identify key predictors and understand hidden relationships in the data. All of these challenges helped refine our approach and made the final tool more robust and accurate.
This demonstration is using the live version of the app you can find at CS6440-group26-diabetes-risk-scoring.up.railway.app. Upon navigating to the website, you'll find the homepage, which you'll be greeted with a login screen. I'm just going to type in our default user, which is user, and password is test. After logging in, a login successful notification will pop up and a take test link will appear. After navigating to the test page, you'll be met with a diabetic risk assessment test. These questions are based on the CDC's Behavioral Risk Factor Surveillance System survey data, and instructions for the test are to read each question carefully, select the answer that applies best to you, input numerical data for the input fields, and be assured that the responses will remain private and no personal identification information will be collected. After completing the quiz, please select the submit button and the random forest model will generate your risk score. Let's review an individual who may be on the unhealthier side of the spectrum. So they have been diagnosed with diabetes. So have you been diagnosed as pre-diabetic? We're going to say yes. Have you ever been told by a healthcare provider that you have high blood pressure? Yes. Have you ever been told by a healthcare provider that you have high cholesterol? Yes. But we have had our cholesterol checked in the past 5 years. Our current body mass index will be around 34. We do not currently smoke. We have not had a stroke. Currently, we have not had a heart attack or been diagnosed with heart disease. Have we engaged in physical activity though? We have not. Have we had a serving of fruit per day? Yes, we have, but we have not had a serving of vegetables per day. We do consume what the CDC would consider as a heavy use of alcohol, which is 2 drinks a day per man and 1 drink per day for a woman. We do have access to healthcare services, but we have avoided seeing the doctor because of cost concerns. And overall, we would say our health is fair. In the past 30 days, we have felt kind of stressed. 10 of those 30 days, we've felt stress. And for those same amount of days, we have felt physically unhealthy. We do have difficulty walking stairs. We are a male, and we are in our mid-50s. We have some college, but we make around the middle of the road for the income levels. So if we submit this, the data is now being passed to the back end and processed by the model. And we have a reported around 62% for our risk score according to the AI model based on the training set. A little blurb pops up just saying where this data was collected from, where you can find the data, that this model does not substitute as any medical advice, diagnosis, or treatment, but it does say that we have slightly above 50% risk of developing full-blown diabetes. So let's go see our statistics page now. The next page of our app is the statistical view. Here we have a drop-down menu full of different graphs to view the CDC's behavioral risk factor surveillance system survey data and how it pertains to diabetes to helpfully communicate a deeper understanding of patterns and trends of diabetes as related to different factors such as smoking, age, body mass index. So if we go over here to this dashboard of diabetes factors analysis, it's actually going to generate a few different graphs. The first being body mass index distributed by diabetes status. As you can see, diabetes tends to come with increasing body mass index. However, there's a wide distribution around the norm. High blood pressure versus diabetes status, physical activity versus diabetes risk, and age distribution of diabetes statuses. So status 0 would be non-diabetic, status 1 would be pre-diabetic, and status 2 is somebody who is diagnosed with diabetes. We have several more graphs for everyone to explore, and I encourage you to do so. And the last page is our diabetic prevention and management resources page. So this page has several links from different sources, including the CDC and American Diabetes Association, to help prevent and manage diabetes in people who are at risk. Topics include diets and exercise advice.
For future work, we are building on the strong foundation we've already set. One key step we've already taken is implementing a gradient boosting model, which is a powerful machine learning technique to enhance the accuracy of our diabetes risk predictions. Going forward, we plan to refine and tune that model by testing different hyperparameters and evaluating it against more robust performance metrics. Another big area that we want to cover more extensively is personalization. Right now, we rely on the structure of the Kaggle dataset to guide our questions and risk calculations. In the future, we'd like to go beyond that by incorporating more detailed health history from users, like family history of diabetes, current medications, or lifestyle habits, to make the risk assessment more tailored. Another important step is expanding our dataset. The Kaggle dataset is a great starting point, but it has limitations in terms of diversity and the range of risk factors it includes. By incorporating the other datasets, including CDC data or electronic health records, we could provide more accurate and equitable predictions, especially for underrepresented populations. We'd also love to give users the option to upload or connect their own health data. This could include wearables, lab results, or EHR integration through FHAR, IR APIs. That kind of input could really elevate the tool from a static risk calculator to a dynamic, personalized health assistant. In terms of education, we think there's a potential to build interactive content that helps users understand their risk factors and take action. For example, if a user is at high risk due to high BMI or glucose levels, we could provide targeted content or community resources. And finally, we want to finalize our deployment pipeline so that hosting is seamless and scalable. That means choosing the right platform, handling CI/CD properly, and ensuring the tool is always accessible to end users.
To wrap up, our key insights centered on balancing simplicity and accuracy in medical risk factors. Simplifying too much risks losing crucial details, while too much complexity could overwhelm users. Integrating the front end and model required close coordination to ensure everything works seamlessly. Deployment faced challenges due to compatibility issues with Streamlit, Docker, and the hosting platforms. So moving forward, we need to find a more stable and cost-effective deployment strategy. Reflecting on the process, cross-functional teamwork was essential, from pre-processing and model development to front-end design and deployment. This project also reinforced the value of user-centric design, especially in the healthcare field. Balancing technical complexity with usability required continuous iteration and team alignment to ensure a practical, user-friendly tool. And future versions must include user testing to improve input clarity and overall experience.